So now I know that it's lots of contents and lots of topics that the courses address, but I'd like to see the opinion of Professor Bouras. What do you see as the main challenges and opportunities for the implementation of the Ceres course in different educational and regional contexts, especially considering your experience in teaching in different countries? So you can go.
Yeah, thank you very much for this introduction. And I have to give just my opinion as an IT person on these courses. So I don't have the ambition to give you my feedback on everything. But as an IT person, I found that the provided courses are really a wonderful opportunity for the students and the learners because they provide a holistic picture of the circular economy chain. Definitely, this will prepare them to create more accurate and more tangible solutions for the current issues that we know when we talk about circular economy, such as the end-to-end visibility, the minimum of information integration, interoperability, reliability, agility of the systems, and so on. So implementing these courses in different learning models, I've seen that you are targeting the normal, the classical way, and also the vet collaboration with the industries. So this is really fantastic because it offers really several advantages for the students, particularly in aligning them and their skills with the sustainability and green economy demands that we have seen today, not only in Europe, but everywhere. Such models equip the students with practical and in-demand skills for the growing needs. As we said, for example, we are talking a lot nowadays about recycling, waste management, remanufacturing, sustainable construction, eco-design, etc., etc. And this definitely will help also the local industries which are seeking more and more for a transition to circular business models. Overall, from the IT point of view, as I told you, so I really like the digital transformation feature in the courses because I found it as a wonderful opportunity to explain to the students mainly the notion of trustworthiness. This is a huge issue that the students read or need really to understand because applying technologies in the complex systems, in the current systems looks easy, but it's not easy at all. So we can, of course, have different levels of technologies, but at the end, we are not sure about the responsiveness of our system. So the notion of trustworthiness is the attribute of a system having the necessary security functions and assurance to provide confidence to the stakeholders about the capabilities to perform reliable tasks and fulfill assigned responsibilities. So in terms of safety, privacy, security, reliability, resilience, etc. So all these notions are really interdependable, and I've seen that in the courses you are addressing most of them, and this is really something very important. The trustworthiness, if you see, for example, in the Industry 4.0 applications, and mainly in the cyber-physical systems, for example, you will see that this is one of the main pillars to really be sure that the cyber-physical system is responding properly and that we have a confidence in this system. And NIST, the National Institute of Standards and Technologies, for example, implemented a standard, and one of the pillars of the cybersecurity systems, as I said, the cyber-physical systems, in that standard is the trustworthiness. It's not easy to define, but it is mandatory and very important to understand. I've seen that you are talking also about the blockchain technology, and I guess that there are some case studies related to this technology, which is very important for the students to understand that the blockchains are also playing a pivotal role in ensuring the transparency, the trust, and security in the industrial processes, either in the production, logistics, supply chains, etc. However, they have really to understand that this is not easy to implement because it has some limitations and because of the complexity of the industrial information systems. Contrarily to the systems for financial applications, for example, cryptocurrency, etc., where the information is simple, here, as you can see in this figure, we have really different kind of transactions when it comes to the industrial system. It can be orders, documents, technical specification, invoices, processing data, information processes, etc. And it is really not easy at all to incorporate this in the blockchain. If really you go deep, you are duplicating the information system of the company, and that creates huge problems for the supply chain. So, but as a technology, so we have to secure the information, the transactions, and we have to select actually what is the information in the industrial system to preserve, to guarantee, and to secure. Another feature in the courses that I really liked is the consideration of the life cycle vision. It is very important for the students to understand that any product should definitely maintain its compliance with the industrial standards through its whole life cycle, through the entire life cycle, the beginning, the middle, and the end of the life cycle. From raw material sourcing to processing, packaging, distribution, consumption, reuse, etc., etc. And the good thing today, from the IT point of view again, is we have more and more AI solutions, algorithms that can predict, for example, the potential disruptions in the supply chains and manufacturing, ensuring operational continuity and product integrity. This is really very important for them to understand and to use such tools. However, we have also to be sure that they understand and they are aware about the cost of such technologies and the digital technologies in general. So the AI is becoming somehow a problem for the environment because AI algorithms consume massive amount of energy. AI drives the heat and carbon emissions, for example, and generate a huge number of data. So the students should really understand that we have to use such technologies because it helps us making smart solutions, but in the same time, they should not use such technologies just to use them because it's fashion to use them, but really to use them when it is really needed. Otherwise, they will create for the companies and the supply chain and the circular economy other problems related to the environment, related to the data storage, and so on. When it comes to technology and to these kind of tools, the software, etc., we always say to our students that before you start implementing the solutions, you have to think about the processes first. And before going deep in the technological side, so they need to understand the underlying processes, reference models across the life cycle phases of the product. For example, so this is just one of the examples. If they are thinking about the data in their application, so before implementing anything, any software related to the data, they have to understand where is the data, what are the performance indicators or the best practices related to this data, who defined this data, which processes are using now and tomorrow this data, what are the evolution description, the responsibilities about the data, who is the owner of the data, is it the design, is it the production, is it the logistics, etc. The processes that are using the data, is it the planning, manufacturing, price calculation, the associated documents, we have thousands of documents related to the data, specification plans, things like that. So it is very important that they understand that everything is connected and that any software should respect the reference models related to the data, to the product, to a lot of things. So I think this is very important for them to understand before just digging into the AI and these kind of things. Sorry, I think I have to stop here. I think I'm going to another question. Yeah, so these are